Okay, so let's take a look at the ticket question. Okay, let me read a while to recap. Tickets were 5, 12 for each child during weekend, Saturday. Oh, okay, so there's a Saturday and 2 days. Okay, so of course the model, how I will do this is I will use the model. So this is something like a before and after. Something like a before and after type of question. So this is like on Saturday is before. Is before. Right, and then this is the plus or minus, and then this is the after. So this is the Sunday. So the tricky part here is about the percentage. You see the okay, so you see the first sentence, right, is actually very distracting. They tell you $5, $12. You don't have to use this until the end, right? Because at first you have to figure out what is the correct change. What is the correct change over here before you can do the rest. So on Saturday there were 120 more adults than children. Yeah, so over here, and on Sunday the number of children increased by 20%, number of adults decreased by 10. Okay, so on Sunday you have a total of 927. So 927 over here. So the tricky part is coming up with this table over here, right? So uh, uh how come, right? Why you go and put 100U? How come? Okay, 1U also can. So actually the you want to put 10U also can, 1U also can, 100U also can, want to put 1000U also can. Yeah, but why they put 100U is because of percentage. You want to make it easier for yourself, right? Because when they say increase by 20%, and if you just add 20, you just add 20. Like for example, if your children, right, you start with 1000. Let's say you like 1000, you put 1000 units here. This has to be plus 200. Yeah, you'll end up with the same thing, but then your numbers will be big. That's the only issue. You get really big numbers. Like if you want to put 1U also can, but then you will get 0.2. Here will be 0.2. Okay, so sometimes I put 1U, because you don't know what's going on, so you just put 1U here, then here 1U plus 120, right? And then when you do halfway, you realize, 20%, no, 20% of 1U is like 0.2, then you end up with decimals which you have to deal with, right? Then you can go and change, just change to 100 units. You know what I mean? Yeah, so they put 100 units here is for convenience. Yeah, it's for convenience. There's no specific rule saying that you must put 100 or 1 or whatever, right? Also comes with experience. So let's say here is 100, and then we try to see whether the model can fit the criteria. So first part, children 100, then plus 20, so become 120. Okay, so this one okay, right? The children part okay, right? Okay, next we look at the adults. So the criteria is that first of all, there must be 120 more adults than children. So that's why we have this thing, 100U plus 120. Okay, then after that is the tricky part. So the tricky part is the decrease, right? Decrease by 10%. Yeah, so this is the part where a lot of students, they will be stumped, they'll be stuck because they do not know how to remove 10% from here. You know what I mean? Like if it is 100, right? Oh, I just minus 100U lah. But then now I have 100U plus 120, how to remove 10%, right? So this comes with experience. Removing 10% from an equation like that, you have to take from both parts. You have to remove from both the units as well as the number. So here you minus 100, 10% of 100 unit is 10U. Yeah, then 10% of 120 is 12. Yeah, so you got to remove from both sides because both of them add up together to become number of adults, right? So if you minus 10%, you got to remove from both, so you get this. Okay, and yeah, so you can then tabulate what is your final. So you get 120 units here because you add 100 plus 20 is 120, and then this one 100 units minus 10 you get 90 U, and 120 minus 12, take away 12, you get 108. Can, right? So this is the before and after, and total. So you compare the total. So total 927 is equivalent to the summation of these two, right? And then you can find units, right? Because 120 units plus 90 units gives you 210 units. Yeah, and the number is just stand alone by itself, and the 927 is over here. It's 927, right? So yeah, I mean you do the usual, you find that 1 unit equals to 3.9. And then here also confusion sometimes. Because you get a decimal, right? Then you worry that, no, how Okay, so the reason why you're getting a decimal is because you have uh I mean it doesn't matter at this point of time. It's okay. Why? Because your units are very big, so that's why you get decimal, because you use 100 U so sometimes you get decimal, right? And okay, this is not the final solution, so let's see what we need. Not complete. So they want to find out what was the total amount of money collected. So before that, I need to find out how many people are there. How many people are there, how many children, how many adults and all this, right? So let's use the value that we found. Now if 1 unit is 3.9, this 100 unit will be, okay, let me just set up another table so we can fill in. So children, adults, okay, so this is a Saturday, so we continue from here. So this is 390, right? Because we take 3.9 times 100, right? And then this number of adults is 390 plus 120, yeah. Okay, then we can calculate. Okay, let's look at Sunday first, since we are doing. Right, so this is 120 units. So you gotta multiply, we get 468. Yeah, then this should be 3. Calculate 3.9 times 90, 351 plus 108. Okay, so now we have the total. Oh yeah, 351, 351 plus 108. So now we have the total number of people over there. Then we use the value. So this is a $5 each child, $12 each adult. So child is $5 each, $5 each, and adults is $12 each. Okay, so let's find the total number of children. It's like 390 plus 468, 858 times 5, right? It's 4,290. 4290. Okay, next one. 390 plus. Okay, so this is 969. Then times 12. 11,628. Right, so the question is, what is the total sum, total money collected on both days? Just add them lah. Just add these two together. So 1162 plus 4290. Okay, this answer should be $15,918. Yeah, that's it. Okay, so that's for this question. Okay, I was looking at her answer, and I think she's trying to look at the difference, you know, trying to find the difference, but I don't really understand the rest already from here onwards. It's like she's trying to find the difference and then from the difference try to minus off. Yeah, is a wrong direction, going the wrong direction here, because like what I mentioned, she got sideline or confused by the first line, which is like $5 each child. Yeah, by the value, right? So the question doesn't need you to calculate the value first. You have to figure out the number first. You have to figure out the number first. So you see, yeah, a lot of times there is that. In fact, all the time there's no fixed method for a problem sum. Even though you know all the templates, right? You can memorize all the templates, but every problem sum is different, so you have to be flexible. That's what the math is all about. Right, but the template definitely help you lah. Like you know value and units before and after, you know, they will help you answer questions faster. Yeah. All right. Okay. Yeah. 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 I mean, yeah. If you want to do it this way, I think probably can, you know, but it's going to be quite complicated. Yeah. Like I don't understand what. You mean this one, the one at the top, is it? Uh. Yeah. Because you cannot see mah. You cannot see what's going on, like the whole picture. Yeah, using before and after, you can immediately understand what's going on. Yeah, just by one look. Checking is also easier. Okay. Okay. Any other questions for this? No. Okay. Continue. All right. This is the XYZ. Okay. Look. Okay. So XYZ, three boxes. XYZ.